Shahidh. I work on Kubernetes, mostly on building tools around Kubernetes to make it easy for developers to use it. Um, and I work at a company called Hasura, where we build GraphQL on Postgres. So you can plug Hasura in front of any existing or new Postgres database and get uh, GraphQL APIs with authorization and without writing any resolvers or schema. So that's about the company. And yeah, you can find me on Twitter. So I'm here to talk about Git push, the thing that we know that we do every day, all the time. So I believe there isn't anybody here who use something other than Git for version control. Is there anybody using Mercurial, SVN? Okay, cool. How many of you have used Heroku? Heroku users? Yeah, couple of them. So Heroku introduced this idea of you having your source code and then you make changes in your system and then you just do git push Heroku master. Suddenly your code is live on a URL. You can share it with anybody. You can see what's happening real quickly without having to go through a DevOps team or somebody who is really good at managing servers and stuff. Every developer could get their app deployed very instantly. That's a power that Heroku brought into a lot of developers, mainly application developers. On that note, how many of you are application developers? Okay, and DevOps or operations? What about the rest of you? What do you guys do? Okay, no problem. So, if you have used Docker and Kubernetes, this is what your normal workflow would look like. You would write code, you will have a Docker file, you do a Docker build, you do Docker push, then you use kubectl to edit the or set the image name to the new image that you built. So it's a three-step workflow, and if you're building something like Java or Haskell or something that's heavy, and if you're not using an Alpine or Scratch-based image, the push and the Docker pull after that itself is going to take some time if you have like 1 GB, 2 GB kind of images. So what we did when we wrote Gitkube, it was an internal tool at Hasura that we used. And then me and my colleague Thirumare, who sadly could not be here because of other engagements, we made it open source and called it Gitkube. And this is what Gitkube does to your three-step workflow. You just have to do commit and then push. So this is made possible by using something called Git hooks. And Git hooks are awesome. How many of you have used Git hooks? Oh, okay, that's a huge crowd than I normally see. So I have a Git hook on my, I put this in most of my repos, where whenever I commit, I make sure that the hook will check, it's a pre-commit hook, it will check that I have had a change in the changelog file. Otherwise, what happens is whenever we make changes, we commit, 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 and finally it's time to release, the last commit on which the release is tagged would be update changelog all the time. So you can extend the functionality of Git by using Git hooks in very different ways. And we are interested in these particular hooks. So you can find these hooks in the .git/hooks directory in your system, in your local Git repository. And if it is a bare repo, which is on the remote where you push to, you can find it there as well. And some hooks are client side, some hooks are server side. And we look at pre-push hook, which is the client-side hook, which is executed before the push is, before the objects are sent to the remote. And any error in this hook can stop the push. Same with pre-receive hook. It is on the remote, executed right after the objects are received, but before they are committed into the tree. So this also can abort the hook, and you can do a lot of fancy things here. I will show you that in a moment. And there's another one called post-receive hook, which you can use to do stuff after the objects have been committed to the tree. So it's time for a demo, and I hope the demo gods are with me today. I have a backup also in case the demo gods are not. So let's see how that goes. Okay. Okay. Okay, I can't see anything. Trying to duplicate my screen always gets me. Okay, cool. So I have a Kubernetes cluster running on GKE. It's called Gitkube cluster. And what I have here, is it visible? The font size is okay? Okay. So what I have here is Git repo with this kind of a structure. So I have Nginx deployment, Nginx service, and I have the source code along with the Docker file for the same Nginx microservice. I'm going to be deploying a static HTML file here. So what I do first is I install Gitkube on the cluster. Can be done by using just a kubectl apply command, or we have a CLI which will do it very easily for you. So I'm just going to do Gitkube install, and we have to expose the Gitkube service, and I'm going to choose the load balancer. So while it is getting provisioned, the load balancer and all, we look at some of the stuff here. You can see that manifests has Nginx deployment, which is a Kubernetes deployment, and then there is Nginx service, which is a Kubernetes service. So what I do is I create something called Gitkube remote. This is a Kubernetes CRD, and this is just an easy way of creating it. So I'm going to call it dev in the namespace default. It's going to take my SSH key, and I'm going to say use the KTS manifests from manifest directory. I'm not going to set up a Docker registry for now because I'm going to be using a single node cluster, and this is the name. This is the microservices Nginx Docker file, and the build context is microservices Nginx. This is the directory where you would have executed your Docker build. So don't want another. So I'm just gonna check if my IP has been allocated. Yeah. So now I do gitkube remote create -f remote.yaml. So now I have this remote. So it's gonna tell me this is your remote URL. Okay, it already exists. I git remote remove dev. Should have removed my thing earlier. So now what I do is I just do git push dev master. So you can see it's building the Docker image. It's applying the Kubernetes manifests, rolling it out. So now if I look at the services, it's still pending the load balancer IP. So I did not execute a single kubectl command. I did not do a Docker build. All I did was gitkube, specific gitkube commands, and then a git push. You can totally avoid the gitkube CLI from the picture as well. So the load balancer IP is still pending, and in the meanwhile, okay, still pending. Come on, GKE, come on. Yeah, so I have the IP now. So if I go to, yeah, so I can see something written on the website. So this is coming from this directory, src index.html. And if I just remove this hello, and there's a GIF there, which we're going to find out what it is. And I say git commit add GIF. Oops. And I'm going to do push again. And it's going to rebuild the Docker image. It's super fast because it's nginx, the static file. And I'm going to refresh. OK. And yeah, that's all. So what happens here is I have 2 more minutes. I'm just going to quickly introduce the architecture as well. So not sure where my slides went. Cool. So you have a Kubernetes cluster, and there's a deployment, and yeah. So what you are doing here is when you do git push from your from your computer, you have already set up this Gitkube operator. That's what happens when you do Gitkube install, and it's gonna watch on a CRD. And when you create this remote.yaml, the CRD is getting created. It's gonna configure something called Gitkube D, which is the agent responsible for building the images. And the controller is also gonna give you back the IP or the git remote URL to which you are gonna push. And when you do git push, it's gonna Docker build the image and update the deployment. So this is very simple configuration, and this is the CRD, and this goes well with the pattern of CRDs and operators that Craig was talking about yesterday. And the permission is simple. It's just based on the public keys. And so check it out. Check out Gitkube. And don't think I have any time for questions. I have 2 minutes. So any questions? OK, yeah, there's something. I'll have to throw this, but I don't know if I can reach that far. OK. Oops. Yeah, it did not.
So where's the image actually built? Is it in the built in the cluster?
Yes, the image is built in the cluster, and it's a Docker image that's building the image. And there might be a security concern where you think when you think about this, but the community is working towards this, making sure you can build containers unprivileged in the cluster. But as of now, it's meant to be a dev tool where you can quickly get your code working on the cluster. So I mean, we don't recommend it to be used in an adversarial multi-tenant environment or so. It's a simple Docker build on the cluster. Yeah. So you can avoid the git push, git pull times very easily. Cool. Any other questions? Awesome. So thank you so much. Thanks for being here.